Economic game theory. The study of games is many centuries old. More systematic developments in game theory took place in the first half of the 20th century. John von Neumann and Oscar Morgenstern are publishers of the game theory and economic behaviors and are the main founders. Their goal was applications of mathematical methods to broadly analyze games and a new scientific approach to the study of economics. Used in applications and aided by computers, theory has been broadly applied in large-scale operations such as international trade. So what is game theory? Game theory is the process of modeling the strategic interactions between two or more players in a situation containing set rules and outcomes. While used in a number of disciplines, game theory is most notably used as a tool to aid within the study of economics. You must be asking yourself, how does it work? Game theory's work can be explained in the context of auctions. An auction is a non-cooperative game involving several players. Each player assumes the other player would react in a certain way for every action of their own. A game of chess explains this more clearly. A chess player bases his moves assuming his opponent will respond in a particular way, and vice versa. The strategies and tactics are based on these assumptions. Prisoner's dilemma. The scenario is that we arrested Al and Bill for selling drugs. We brought them into the station separately for questioning. Scenario 1 is an open and shut case. If both are convicted, they will receive 2 years in jail if nothing else happens. We then find out that both were involved in a drug deal a little while ago. Now the situation is to try and make a deal with the incentive for them to snitch on each other. Scenarios 2 and 3 are trying to get one to confess and snitch on the other, and then the other one does not confess, they deny the charges. Those are the results that they will get. One will get 10 years in prison, and the other will get 1 year in prison. Scenario 4 is if they both confess, then they both will get 3 years in prison. This is a prisoner's dilemma. We will see there is a globally optimal scenario where both can deny their charges and both will get 2 years. Based on their incentives and that there is no loyalty to each other, we will see that they may or may not pick an optimal scenario. In the payoff matrix, Al and Bill have two options. They both can either confess or they can deny their charges. If Al confesses and Bill confesses, then we're at scenario 4 where they get 3 years in jail. If Al confesses and Bill denies, then we're at scenario 2 from Al's point of view. Al will get 1 year and Bill will get 10 years. If Bill confesses and Al denies the charges, then we're at scenario 3 where Al will get 10 years in prison for not cooperating and Bill will get 1 year. If both deny, then we're at scenario 1 where both will get their time for drug dealing and Bill and Al will both get only 2 years. Here is a visual of the payoff matrix. On the left we have 4 scenarios from Al and Bill, and on the right we have the payoff matrix with the outcomes if one denies and one confesses. The question is, what is the globally optimal scenario for both of them? Both deny, saying that they have nothing to do with selling drugs because in the end they will both only get 2 years. The problem? Both want to get the Nash equilibrium state of confessing, which is 3 years. Opposed to the globally optimal state of both confessing to get 3 years, they should be denying the charges and only get 2 years in jail. Nash equilibrium is when no single player can obtain a higher payoff or improve their situation by deviating unilaterally from this profile. In the example, first evaluate the different responses for each player. Player 1 in response to player 2, and then player 2 in response to player 1. Nash equilibrium exists when both players choose B, as both parties have the same best response. If one player should choose another option on their own, with no changes by the other player, they would decrease their payoff. Let's take a look at risks and rewards. This dilemma has been studied for decades and tested in labs and simulations. The table to the right depicts the two-person game with only 2 choices. In this table, C is cooperation, D is defection. R represents a reward for cooperation from both parties. S is the sucker payoff, T is the temptation payoff, and finally, P is punishment. This model shows that the two parties will gain over time with cooperation. This has been applied to real-world scenarios like marketing and advertising. If either sides risk defection, they could risk getting a lower payoff than if they cooperated. Zero sum can be defined as a situation in which one person's gain is equivalent to another's loss. Therefore, the net change is zero. In finance, a zero-sum game can refer to trades or investments where one investor gains while another loses. For example, AT&T stock is trading around $100 per share, and investors A purchase a call option on AT&T from investor B. Next month, AT&T stock is trading at $105 per share. Investor A can use that call option to purchase shares of AT&T from investor B at $100 and then immediately sell them at $105. Investor A gains $5 while investor B loses the $5. There are many different applications of zero-sum game theory in the real world. Business examples of zero-sum game include airlines during the 1990s. One airline would cut the cost of round-trip tickets, and another company would lower their price on the same trip the same day. Amazon.com's marketplace offers several different retailers to consumers with similar prices, often within a penny. One more example which we've all seen are the price wars between gas stations that are across the street from each other. Thank you for joining Group 4. We hope you have enjoyed this short presentation on economic game theory.